Good evening, my YouTube viewers. Crystal here. Happy New Year. So this is the first day of January 2021. We're all sitting home in the UK under Tier 4. So I decided I'd make another video since we're under Tier 4. This video is I'm comparing Sweden to Denmark and their new cases and new deaths with regard to COVID-19. The reason why is because Sweden didn't have a lockdown and Denmark had a lockdown immediately. And so what I wanted to do is I wanted to look at the new cases and new deaths at these two neighboring countries. One didn't have a lockdown and one did, and see what we can find out. See if we can glean any information from the new cases and the new deaths. So what I did was I'm on GitHub, and whenever I make my blog post, I'll give you a link to the blog post, a link to my GitHub account on my blog post. So that'll be a good incentive for you to actually read the blog post. But I like doing the code reviews before I do the blog post because it gives me a chance to find mistakes, because I have actually found mistakes in my code when I was doing a code review. So that's good. When I use this data set that I got from New World in Our World in Data, and this data set it's updated every day. So every day that you do work on this data set, you have to make sure that you have uploaded the most current data set. And this morning I uploaded the most current data set. I wrote the program on Google Colab, which is a free online Jupyter notebook that's got many of the libraries already installed. So all you have to do is import them. And Google is not paying me to promote them. I wish they were, but I did use Jupyter Notebook on that. So the first thing we did is, because many of the libraries are already installed, all I had to do was import pandas and NumPy. So that's just a standard thing that you need to do anytime you make a Python program, because you're invariably going to be using functions from those two libraries. And then what I did was I read the file. The file was so big that I was not able to store it on my GitHub repository, which is what I would have liked to have done. So I've had to store it on my Google Drive, and I'll have to reload it onto the Google Drive every day that I work on it. Here it is. We're just checking to see information about this data set. So most of the columns are floats, but there's a few object columns in there as well. So now what we want to do is we want to convert our date to a number. And the reason why is because when we go to do the predictions, then what's going to happen is the model is going to want to see a number. The only model that I know of that will handle categorical features is Catfish, and then you still have to do some stuff to it to get it to work. So what we've done is date equals train.date, train date equals PD to date time, train date errors equals coerce, train date num equals train date dot dt strf time, and then the format and train. So if we go over here, we can look at the very end, the very last column, and you can see that the date has been converted to a number, which is what we want to see. So what we want to do is we want to see which countries are covered by this data set. So country equals train.location dot to list, and we've created a list. The list is empty, but what we've done is any country name that doesn't appear on the list, doesn't appear in the column, is actually going to go into the list. So we've got that, and you can list the country. So we've got 192 countries on the list, and somehow or other, one of the countries fell out, and I don't know why it fell off, but it did. We have 192 countries, but when we look at our data set, it's only 191 countries. So one of the countries has fallen off. And now what we have to do is we have to manipulate the date. The reason why we manipulate the date is because when we do our prediction, we have to have the most current date. So we import date, time, date, and we import date, time, time delta. So today equals date dot today. And you print that and you'll see it's 21/1/01. That's today. Yesterday equals today minus time delta days equals 1. So that's 31/12/20. Last date equals train.date.next. So that was 31/12/20. And then so we want to find out what type of variable last date is, and it's a timestamp. And then yesterday equals PT timestamp yesterday. So what we want to do is we've timestamped yesterday. And then what we want to do is we want to find out what type of a variable yesterday is, and yesterday is now a timestamp. I used an if else function command to do some things that I wanted to do. If last date equals yesterday, last date equals yesterday. If last date greater than yesterday, last date equals yesterday. Else, last date equals last date. And then you print the last date, and the last date is 31/12/20. So now you can see the last date. This is the last date that we have printed off. It's 31/12/20. That's what we want to see because it's yesterday. And then now what we've done is we've just done a little chart of the new cases, and we've done another chart of the new deaths. We've done another chart of the new cases according to the country, and you can see, I believe it's North America that has the most cases, but I'm not sure. For the United States. And then now we do the new deaths on the location, and I believe it's the US that has the most deaths as well. So now what we do is we prepare a little box plot, and this box plot, you've got the new cases. It says North America has the most new cases, but I believe it's because they're doing the most tests. We do another box plot on the new deaths, and North America has the most new deaths, but I believe it's because they do a lot of testing. Now we've got a heat map, and what this heat map will do is, if you like heat maps, you can analyze how the independent variables fit in with the dependent variables. So now what we're looking at is the UK, and I used some coding to filter out the UK so you can see the UK, and that's the UK data set. So what we wanted to do was we wanted to look at the new cases per million in the UK, so you can see that it's going steadily upward, and the reason for that is because we've got a new strain of this virus coming out of the UK, and it's much more infectious than the original strain. So we look at the new deaths per million. Let me just look at this. Yeah, now we look at the new deaths per million, and again, you can see that the new deaths per million are increasing to almost as much as they had in the spring. And the reason for that is because we've got that new strain of the virus that's much more infectious than the original strain, and they're trying to contain it. Now we're looking at the U.S. So we use some filters to filter out the United States so you can see the data frame for the United States. Now we're looking at the U.S. new cases per million, and as you can see that the new cases started out small and they're gradually moving up. The same thing with the new deaths per million. We've originally had a lot of new deaths and then it tapered off, and now we're getting more deaths as well. And this new strain coming out of London has actually made it to the United States. Now we're looking at China. China is where the virus is believed to have started. And so we filtered out China so you can see China's data set. We've got the new cases per million, and you can see that they had an initial spike and now they don't have any new cases. But if you look at my last blog on the subject, I discussed the reason why they're saying that they don't have any new cases. So I really wouldn't trust the data that they're giving. The data that they're giving is not really reliable. And so if you want to analyze their cases, you can't trust it because the data is coming from the government and it's not reliable. They're saying that they don't have any cases, and I don't think that's true, and I think most people don't think that's true. And the next thing you do is we're looking at new deaths, and you can see that they had a big spike in the beginning, and now they haven't had any more deaths with the coronavirus. And one of the things that they do in China is if a person has the COVID-19 and they die, then what they will do is they will put the secondary condition as the cause of death on the death certificate. So if they had heart disease and they got COVID-19, then they'll say that they had heart disease. So as a result of that, that's why they're saying that they haven't got any deaths from COVID-19, because they're putting a secondary condition on their death certificate. So now we've got the country, Taiwan. We use filters to filter out Taiwan. And look, we've got our new cases per million. Taiwan's new cases per million are a little bit more than China's, but it's still quite low. And we look at Taiwan's new deaths per million, and again, Taiwan is saying that they've not got any more deaths. And I don't know if this has anything to do with the way they record the cause of death on their death certificate or not, but I just think that I would not use their data, because Taiwan and China both have incredibly low rates of disease. I'm not sure exactly why that is, but because their data is not falling in line with the norm, I really wouldn't use their data personally. Now we've got South Africa. We've got a new strain of the virus coming out of South Africa. So what we did was we filtered it out, and you can see South Africa's data frame. So here we go. We're looking at new cases per million. And again, we've got a new strain of the virus coming out of South Africa. And as a result of that, the new cases are climbing up again. So we're going to look at the new deaths. Towards like the middle of the pandemic, the new deaths spiked and then they lowered. But now that we have a new strain of the virus, again, the deaths are climbing up. Now we look at Sweden. Sweden is important because Sweden didn't have a lockdown. So what we've done is we used filters to filter out Sweden, so you can see Sweden's data set. We look at the new deaths of Sweden, and you can see that it started out pretty low, but now it's gotten really high. And I think that that might have something to do with that new strain of the virus coming from the UK, because the new strain of the virus coming from the UK is highly infectious. Now we look at new deaths per million. When we first had the pandemic, there were a few deaths in Sweden, but then it seemed to taper off, and now we're getting a lot more deaths. And I think that is to do with the new strain coming out of the UK, because the UK is relatively close to Sweden. Now we check Denmark. Denmark is one country, it's a neighbor of Sweden, and it did have a lockdown. It had a lockdown immediately as soon as the pandemic broke out, and we've used filters to filter out Denmark. So you can see Denmark's data frame. So now you can look at Denmark's new cases per million, and as you can see, it started out really low because they had the lockdown, but now it's escalating, and I think that may have something to do with this UK strain of the virus that's much more contagious than the original virus. And now what we are looking at is the new deaths. And again, at the beginning of the pandemic, you had some deaths, and then it tapered down, and now it's escalating again. And I think that this escalation is to do with the new strain of the virus coming out of the UK, because UK is relatively close to Denmark. So now what we're going to do is we're going to compare new cases per million to new deaths per million. So we have a lot more new cases than we have new deaths. And that was in overall. That was overall. So all 191 countries or 192 countries. And now what we're doing is we're checking the US, and we're checking new cases per million against new deaths per million. And so you can see that there are a lot more new cases than there are deaths. Same as the UK, you have a lot more new cases than you have deaths. So now what we want to do is we want to compare the individual countries. And so what we had to do was we had to take off the first 7 rows of the UK data frame to make it compatible with the other countries. We had to take off the first 16 rows of the US data frame to make it compatible with the other countries. We had to take off the first 16 rows of the China data frame to make it compatible with the other countries. We had to take off the first 22 rows of the Taiwan data frame to make it compatible with the other countries. We had to take off the first 6 rows of the Sweden data frame to make it compatible with the other countries. And we had to take off the first 11 rows of the Denmark data frame to make it compatible with the other countries. So now what we want to do is we want to create variables for date and the new cases per million and new deaths per million for each data frame that we have created. So it's the UK, US, China, Taiwan, South Africa, Sweden, and Denmark. And so now we've created all these data frames. We've got a UK data frame with a date, UK new cases per million, UK new deaths per million. We've got an identical data frame for the US. It's just this US information. An identical data frame for China. It's just got Chinese information. An identical data frame for Taiwan. It's just got Taiwan information. An identical data frame for South Africa. It's just got South Africa information. An identical data frame for Sweden. It's just got Swedish information. and an identical data frame for Denmark. It's just got Denmark information. And so now what we've had to do is we've had to take all of those data frames and we have merged them. But when you merge a data frame, you're only allowed to merge 2 data frames at a time. So I had to use a lot of merge commands. Now what we're doing is we're checking for any null values in our data set. And we do have some null values, but all of the null values are in numeric columns. So what we've done is we filled all the numeric columns with 0. So now what we've done is we're comparing the Sweden and the Denmark new cases per million, and you can see that Sweden didn't have a lockdown, so it has a lot more new cases per million than Denmark does. And we're comparing the Sweden and the Denmark new deaths per million. And Sweden didn't have a lockdown, so at the beginning it had a lot of deaths, and now it's having a lot of deaths as well. Whereas Denmark had a lockdown, and it's a lot more level than Sweden is. So now what we want to do is we want to put things in perspective. So we want to put UK into the data frame and see where UK fits in. So UK's figures are similar to Denmark's figures, and UK has had a lockdown as well. And that was for your new cases. And now we've got our new deaths. And so UK has had a lot more deaths than Denmark. And a lot of the reason for that is I don't really want to say too much about that because of where I work. But I know I can tell you just from my personal firsthand experience that I was in the lockdown and I couldn't get in to see the doctor, and my boyfriend couldn't get in to see the doctor. And a lot of people who had chronic illnesses or cancer or heart disease, they were not being treated. And so that's the only thing that I can do. I can tell you my personal experience and my boyfriend's personal experience, but I think a lot of this is to do with the infrastructure in the UK. And I think I can say that without going into too much detail into exactly why that is, but it's the UK infrastructure. And so that's why it is. But they are trying to contain the deaths. They're doing their best, I will say that. Now what we're doing is we're checking for any null values in the trained data set, and you can see that there are quite a few null values. So the first thing that we have done is we've dropped the date from the trained data set, but then what we've done is we've just used a filter to filter out the columns that were not numeric. And so what we did was all of the columns that were not numeric, that we just, if there was a null value, then we just replaced it with not listed, and we just essentially created another category. And since we did that, we were able to just fill the train, all of the null values with 0. Now what we're going to do is we're going to use the ordinal encoder. And when you use the ordinal encoder, what you're doing is you're ordinal encoding all of the object files, object columns. And so all of the object columns were put under the ordinal encoder, and all of their values were given a numeric value. And after that, what we do is we define our X and Y. So ISO code equals train.iso code, Y equals train.new deaths, and X equals train, but then we drop a whole bunch of columns, and you can see all of the columns that we've dropped. And now what we do is we're going to put X under a standard scalar. We're going to use the standard scalar command to do that. And you can see Y, and you can also see X, which is now an array. Now what we're going to do is we're going to use train test split to split the data frame up to for training and validation, and the validation set is going to be 10%. Now what we've done is we've selected our model, and I selected HIST gradient boosting regressor because it was designed specifically for large data sets, and I'm working with a large data set. Now what we're going to do is we're going to predict on the validation set, and I got an 88.32% when I predicted on the validation set. You can see our Y-val, and you can see our Y-train values, and you can see Y-pred. And so we put that on a chart. Chart doesn't look very good, but you can actually see how the predicted values correspond with the actual values. So we put our predictions on a data frame so you can compare the actual deaths to the predicted deaths. Now what we have to do is we have to create the data set, and we create the data set based upon the information that we calculated at the beginning of the program. So test equals last date dot copy, test date equals today test. So today's January 1st, 2021. So it calls up all of the rows for January 1st, 2021. But what it does is if you come over here to date num, it's still on yesterday's date. So what we have to do is we have to take that date and we have to convert it to a number. So test date equals PD to date time. Test date errors equals coerce. Test date num equals test date DT STRF time, and then the format and test. So you can see test here. We've got the date as January 1st, 2021. And you can see date num as 101/01/2021. So it says actually converted the value. So now what we're going to do is we're going to check for null values for the test set, and we're going to use exactly the same format that we used for the train set. So we tested for any missing values. You can see where all the missing values were. So now what we're going to do is we're going to impute the missing values. So predict date equals test date. Test equals test dot drop. Test drop date axis equals 1. So now what we do is we filter out all of the object columns, and then what we want to do is we want to impute all of those object columns with any null value is replaced with the word not listed, and basically that's just creating another category. But I just made the decision that I didn't want to say mode because we don't know what information that it holds, and it's better just to put not listed in there. So now what we do is we're going to impute the numeric values to 0, since the only thing left is numeric values. So you can just do it on the whole data set. Test equals fill in A, 0 in place equals true. So that way you don't have to worry about imputing each and every column. And I think that that's a good thing to do, is when you have to impute a value, you go through all the objects columns first and impute all them, and then after you've got the object columns imputed, then you can go through and you can fill your train. You can fill it up with a median or with a mode or with a 0 or anything that you want. So now we have our test set with all of the null values filled in. But what we want to do is we want to put the test set on an ordinal encoder. So test country equals test location, and then you can see the test country. So you can see all the countries there. So now we've put all of the categorical columns on an ordinal encoder. Now what we're going to do is we're going to define our X test. And when we define our X test, we're going to do it exactly the way we defined X. So X test has got exactly the same columns that X has. Now we're going to put X test on a standard scaler just like we did X. And so you can see X test has an array now. Now we're going to predict on the test set, and after we have predicted on the test set, we're going to create a data frame with the country, predicted date, and the predicted deaths. So we're only making a prediction for one day. So that concludes it for this video, and that concludes it for this code review. If you like my code review and you like this video, please like, subscribe, and share. If you like the work I do and you want to leave a donation, I will have my email address to my PayPal account in the description box down below. I don't have enough subscribers to monetize, so the only way I can make any money off my account is to ask for donations. I will be making a blog post based upon this code review, so it really was good for me to give a code review so I could find any mistakes before I do the blog post. So thank you so much for watching this video, and I look forward to making more videos for you to watch in the future.